Hi everyone. What you're looking at right now is what is called a latching relay. And these relays are really cool. I like them a lot. What's interesting about them is, if you see here, this is basically the relay flip-flopping from side to side. And these relays flip to one side and stay there with just one pulse, and then flip to the other side and stay there as well, again with another pulse. And I'm using that relay to control two other relays, which this one will control the positive and negative for the coil to go one direction, and here's another relay that's going to control the positive and negative to go the other direction. So basically the unit is working off these three AA batteries right now in series, and they're going to my meter here, and we have 3.8 volts about going there, and the motor's consuming, you can see between 0.31 is about the lowest you'll see there, and about 0.46 is about the highest, or 47 is about the highest you'll see there. So I would guess between those two, somewhere around 40 milliamps would be what I would guess that the motor is consuming in average. And here's the motor operating, and what I have is at each end here there's a little micro switch that once the coil comes over, it kicks the latching relay to one side, which kicks one of these relays to the correct polarity for the coil to go the correct direction. And then again on this side here's another micro switch, and that kicks it to go back the other way. So it's kind of like a little wiper motor, and underneath I even have some little springs installed there to help it bounce back on each side. There you'll see there's a spring. So the motor is working nice and smoothly, and if you calculate the power at 40 milliamps at 3.8 volts, that's 0.15 watts. And at this time the motor is working, that it's moving this mass of coil, which is 0.9 pounds, close to 1 pound, and probably just a little bit under 1 pound, and it's moving it exactly 1 foot per second, because this rod is actually 6 inches and it's moving it each direction within 1 second. So every second it's gone this way and back. There's 1 second. So if you look at the time bar on the video, you'll see that you can time that exactly. It'll do a full back and forth every second. So there you go. There's a little bit of a way of calculating the power that there is in this motor, and the power would get much better if I had a two bars like a matrix, dot matrix printer, those little printers. One individual suggested that, and that's a good idea as well. If I would have two of those bars guiding the coil perfectly without it rubbing on the bar. Right now you got a lot of friction of it rubbing on the bar. I've got oil on it and all that, but anyways, there you go. So the motor is now working without a signal generator, and I can input whatever voltage I want now into it. Now mind you, the more voltage I put into it, the faster it'll start pulsing, but the harder it's hitting each side here, each magnet. And right now at this voltage and everything, it's working nicely and smoothly, so wouldn't want to really increase it. this is just to give you a little idea of what I'm doing, playing around with. And right here, this battery is pretty well a dead 9-volt battery, and it's got about 5.5 volts remaining, and that's what's driving the coil inside the latching relay, because that requires 5 volts. And these leads here are 12 volts coming in for the coils of each one of these relays to kick the coil from going to each side here. And on this side here, this is the input of the 3 AA batteries in series going to the meter there, and there is the data on the meter there. So the motor's been working for probably about half an hour now, and keeps working very, very smoothly and nicely. Makes me think of wipers going back and forth, the sound. Anyways, I thought I'd do this little video to show you what I'm playing around with. And here's a couple of coils here that I cut open today, and that's for testing another possible motor combination. And it was to test these coils in a opposing field, and checking out to see what the results are with coils in opposing field. And there doesn't seem to be any counter back EMF happening with these two coils in opposing fields when they come by each other. So I'll be probably looking at building a motor with that kind of concept as well to test that out. So that's going to be the next project coming up as well. I'm not saying this is the end of this motor here, but you know, we have to look at different possibilities as well. So that's about it for now, and keep watching, and I'll keep posting new stuff. Thanks. Bye.